Hello, good morning student. Today we are going to discuss about two important concepts in vectors. One is position vector, another one is displacement vector. Okay, one by one we will see. First we are going to discuss about position vector. Let us see. Here I am going to consider first position vector. Consider the coordinates axis x and y. XY coordinate axis consider. Cartesian coordinate axis. Generally we consider. So this is the origin and it is represented with a point 0, 0. Origin point we are going to represent it with a 0, 0. So this notation we call it as ordered pair. And this is called first, that x is called x coordinate, y is called y coordinate. First coordinate or x coordinate. Similarly, y is called second coordinate or y coordinate. What is the meaning of that? Let us see. If suppose I am going to consider this is the position of a object. This is the position of a object. In a plane, how to represent position of an object? In the ordered pair, in the form of ordered pair, consists x comma y. In the form of ordered pair, consists x comma y. Here this is the x coordinate, this is the y coordinate. What is the meaning of that? From the origin, how much distance I need to travel along the x-axis and how much distance I need to travel along the y-axis or parallel to y-axis. What is this one? How much distance I need to travel along the x-axis. X coordinate means how much distance I need to travel along x-axis. That means x units I need to travel along the x-axis to reach here. X unit. And what is the meaning of that? I need to travel y unit along the y-axis or parallel to y-axis. I need to travel y units along the parallel to y-axis. At the time I am going to reach the position. That is the meaning. What is the meaning of that? How to represent position of a object? We will see. The position of the object, we need to consider x comma y. What is the meaning of that? From origin of this coordinate, how to reach this point? That will be given by this ordered pair. X coordinate means from the origin, just to reach that position, we need to travel x unit along x-axis and we need to travel from that point y units along the parallel to y-axis. Then I am going to reach that position. That position. How to write? Let us see. If I am going to consider, this is the vector from here to here. Vector from here to here. So x units along x-axis. Along x-axis already we discussed. What is the unit vector? I cap. My dear student, if anyone it is not known means go for clarity of physical quantity, scalars and vectors. That concept I explained. After that I explained representation of vector, angle between the vectors, unit vectors, one video I did already. If you want, go and check it. So xi cap, this is the xi cap. What is the meaning of that? X units along the x-axis we need to travel. And what is the meaning of that? Y unit, how to represent this vector? This is the vector. Let us see. How to represent y units along j cap direction. Y units along j cap direction. So x units along x axis direction, y units along y axis direction or parallel to y axis direction, positive y axis direction. At the time I am going to reach this point. What is the resultant of these two vectors? Xi cap plus yj cap. These are the two vectors. The resultant vector. What is the resultant of these two vectors? If I am going to consider this is the one vector along x-axis, this is the one vector along the y-axis I am going to consider. So resultant vector is nothing but from origin to position. This is the resultant vector of xi cap vector and yj cap vector. This resultant vector we call it as position vector. This resultant vector we call it as position vector. That's why from the triangle of vector addition, my dear students, already I discussed triangle of vector addition also in one video. Just that is also once watch it. So this is the position vector. Now it seems to be one triangle. How to use the triangle of vector addition? Two sides of a triangle represented by two vectors taken in the same order. Then the closing side of a triangle is represented by its resultant vector taken in reverse order. So these are the two vectors taken in the same order, and this is the position vector taken in the reverse order. At the time, how to write the triangle of vector addition? Xi cap, this vector, plus yj cap, this vector. Addition of these two vectors will give the resultant vector, that is r bar. That's why we are going to write any position vector in a Cartesian coordinates in this manner. This is the complete explanation how we are going to get position vector xi cap plus yj cap. What is the meaning of this position vector? To reach this point, how to reach this point? X units along x-axis, y units along parallel to y-axis. At the time I am going to reach this position x comma y. That is represented by simply one position vector r bar from the origin to that point. So how to calculate position vector magnitude? This is what x units. This is what y units. This is what r units. Then by using Pythagoras theorem, how to write? Hypotenuse square is equal to side square plus side square. Then position vector is equal to under root of x square plus y square. Now this is the magnitude of the position vector. So this is the position vector concept, my dear student. Just try to understand. Now I am going to discuss about displacement vector now. Second one. Displacement vector. Consider this is the x coordinate, x axis and y axis, and I am going to consider one body at this position, x1 comma y1. I am going to consider initial position is x1 comma y1. Initial position is x1 comma y1. And how to write the position vector? From the origin I need to write the position vector. So this is the position vector now. Origin, x-axis, this is the position vector. Initial position of the object. I am going to consider this the r1 bar position vector. What is the meaning of r1 bar? R1 bar is nothing but x1 comma y1 is the position. What is the meaning of that? x1 unit along x-axis like this, that is x1 I cap, and y1 unit along parallel to y-axis, y1 unit along parallel to y-axis, that is represented as y1 j cap. Then how to write this one? R1 bar is equal to simply x1 I cap plus y1 j cap. That means position x1 comma y1 means how to write simply position vector x1 units along x direction plus y1 units along the parallel to y-axis. x1, how to write the position vector? If x1 comma y1 means position, how to write x1 unit along x-axis plus y1 unit along parallel to y-axis, positive y-axis. That is only position vector R1 bar. So this is the initial position, this is the initial position vector. Suppose I am going to consider the object travels from this position to this position. The object travels from one position to another position, this position to this position. At the time, this position I am going to consider x2 comma y2. That position I am going to consider x2 comma y2. This is the x1 comma y1 position, this is the x2 comma y2 position, and the object travels from this position to this position. The object moves from this position to this position. This x2 comma y2 is the final position. Final position is x2 comma y2. x2 comma y2. Then how to represent? This is the final position vector. This is the final position vector. Final position vector x2 comma y2. This is the final position. Of course, this is the initial position. Now object moves from initial position to final position. So this is the final position vector. From origin to that position is final position vector. Then how to write final position vector? Consider final position vector is a R2 bar. Then how to write the R2 bar? This is x2 comma y2. Now what is the meaning of that? x2 units along x-axis, that means x2 I cap, plus y2 units along parallel to y-axis, parallel to positive y-axis, that means y2 j cap. That means what? x1 units along x2 y2, no? So x2 units along x-axis and y2 units along parallel to y-axis like this. So from here to here, x1 unit, x2, this is x2 comma y2, no? That's why this is x2. x2 units along x-axis, that's why I cap. y2 units, from here y2 units along parallel to positive y-axis, that's why j cap. Now the position vector is R2 bar. Then how to write the R2 bar? x1 I cap plus y2 j cap. From the triangle of vector addition, this vector and this vector and this vector form a triangle. What is the triangle of vector addition? Two sides of a triangle taken in the same order. The sum of two sides of a triangle taken in the same order, which is equal to what? The third side or closing side of a triangle represents resultant vector of these two vectors taken in the reverse order. That's all. So that's why R2 bar is equal to x2 I cap plus y2 j cap. Now this is the initial position, this is the final position. Then this is called displacement vector. Displacement vector is always from initial position to final position. Displacement vector we need to represent from initial position to final position. Student, this is the most important point we need to remember. displacement vector we need to represent from initial position to final position always. So here I am going to consider this is the initial position, this is the final position, this is the displacement vector. This is the displacement vector. Then how to write the displacement vector? Let us see. See, this is the first initial position vector. Observe here. Observe here. This is the initial position vector r1 bar, and this is the displacement vector. Consider s bar. This is the final position vector r2 bar. R2 bar. R1 bar, R2 bar, S bar. Observe here, this seems to be a triangle. In this triangle, two sides of a triangle represented by two vectors. One is R1 bar, S bar, taken in the same order. Taken in same order. Two sides of a triangle. This is the triangle now. If you want to give the name, this is the O, this is the P, this is the Q. OPQ is a triangle. OPQ is a triangle. In the triangle, two sides of a triangle, that is OP and PQ, represented by two vectors, that is R1 bar and S bar, taken in the same order. Taken in the same order. Then third vector, that is closing side of the vector, represented by resultant of these two. Resultant of these two, that is R2 bar. So why? Because these two vectors are taken in the same order. These two vectors are two sides of a triangle and taken in the same order. Then third side or closing side of a vector, that is here R2 bar. In this situation R2 bar, that is taken in opposite order, that is reverse order, represent resultant of these two vectors. So then R2 represents, R2 is the resultant of two vectors R1 bar and S bar. R1 bar and S bar from triangle of vector addition. Now, what is the formula we need to write from triangle of vector addition? The sum of these two vectors, that is R1 bar plus S bar. Why? Because that is the displacement vector. The sum of these two vectors are represented by two sides of a triangle taken in the same order. Then the resultant of these two is represented by closing side of a triangle taken in the opposite order, that is here R2 bar. R2 bar. But we need to calculate displacement vector. We need to calculate displacement vector. Then how to calculate? From here, displacement vector x bar is equal to R2 bar transpose R1 bar to other side minus R1 bar. Now, this is the formula for displacement vector. My dear student, at any problem you need to calculate displacement vector means simply remember, simple trick, final position vector minus initial position vector. That's all. It will give the displacement vector. How to calculate? In any problem, to calculate displacement vector, what is the formula we need to use? Final position vector minus initial position vector. That's all. This will give the displacement vector. Okay, student. In next section, we are going to see how to solve the problems based on displacement vectors or position vectors. Okay, don't miss it. Keep watching. My dear students, please subscribe my channel, like and share. Thank you, my dear students.